Okay, so now for each of these splits, we have to come up with for each of the splits, we have to come up with the Gini and entropy for the left side and the right side, and then do a weighted average of the two. So we need, for here, we need the percentage of records, okay, on the left side. So for each split, then it is a sum of, okay, so this is percentage of records. So percentage of records comes from the grand total. So it will be from I10, okay, I10 going down. The first time it will be going down till I10 only, and then I10 to I11, and then I10 to I12, and so on. So the starting point is always I10, so make that absolute reference, and then you go up to I10. So that is the sum of records divided by the total number of records, which is I32. So I32 is right there. So first time it is just that one record. Okay. Now if you copy that down, you see that the second time it will go down to the starting point is fixed at I10 because we absolute referenced I10. Okay, so I10 to I11 and so on. Okay, so now this will give you the percentage of records for all the income nodes. Okay, so let me put a kind of a marker here so we'll know that that's our income node. Of course, the percentage of records for the right side then will be just 1 minus that, right? So you can just do 1 minus like that. Okay. Now the probabilities are, so now for non-owner and owner. So it will be again sum of here G10, and we absolute reference that through G10, right, divided by sum of I10 through I10. So it will be, okay, it will be that divided by that, and then sum of from here on down to the split level, sum of this column divided by sum of this column. That will give you the proportion of non-owners. That's your P sub 1. Okay, of course, first time around, here is, this one is 1. So the percentage of non-owners then is 1 minus that. Okay. So then Gini index is 1 minus P sub 1 squared. Well, if you want to do it this way, so like start a parenthesis, that squared plus P sub 2 squared. So that will give you the Gini index, and then we can copy okay. Now entropy is a little tricky, okay, because log of 0 will be a problem. So if you have log of 0, So you get an error for log of 0, because that would be like negative infinity, log of 0. 1 over infinity would be 0, right? So that would be a problem. So you have to test whether the probability is 0 or not. And if it is not 0, then we compute. Okay? Otherwise, we have to not compute. So we need to have an if, okay, so P sub 1 is not 0, okay, then we have to further check if P sub 2 is not 0, okay, then it will be minus of each probability multiplied by the log of that probability to base 2 plus P sub 2 times log of P sub 2 to the base 2. Okay. All right. Now, otherwise, you have to put 0. That is for the first if, and for the second if. Otherwise, you put 0. Where is that? Somewhere. Not 0. Okay, so I need a bracket there. All right. Okay. So now we entropy now we have to repeat that for the right side node. So this will be okay, so this will be like sum of G G11 through G31. G31 must be absolute referenced. So divided by sum of that from I11 through I31, and I31 must be absolute referenced. And that would be 1 minus. Now we can copy these two. So we get the probabilities, right? And the Gini and the entropy would be that. So now we have the Gini times the proportion of records. So that would be the row row should change as we copy down, so we'll keep the column the same, plus the right side Gini times the proportion of records, and once again we have to keep the column same and row different. Alright, so we copy that over there, and you get our entropy, the weighted average of the Gini and entropy. Okay. Now, here for this, we can now select the one with the least value, the smallest value of Gini, or smallest value of entropy. Okay, so that's the least impure. Okay. Now, of course, we have to repeat this for the large size. So there are a couple of approaches here. You look at the entire set and select the one that is least, or you can look at the first predictor, select the smallest value. Okay, that would be the candidate split for the first predictor. Do the same thing for the second predictor and select the candidate split for the second predictor, and so on, and then you compare. So that's what is described here. So step 1, comparing splits from single input, okay, and then step 2, comparing the best split from all the input variables. Okay, so it will be a two-step process. So we will discuss that